So we learned how to make a group frequency distribution essentially last time using Excel. Today we are going to learn how to construct graphs using Excel. Once you have a frequency distribution table, you can always use it to construct a graph. So we will start with a histogram, which you have already seen on the last class. A histogram is a bar graph where the bars represent the frequency. We use vertical bars to represent the frequency. You want to be careful about the scale that you are using. Most of the time, we just use Excel, but if you are doing it manually and you don't use the right scale, you might not be able to make it through. So you observe the frequency and use the highest and lowest frequency to determine what scale you are going to be using. We are going to learn how to use Excel to make it. So this is a frequency distribution table, and we want to use it to construct a histogram for this distribution. So I'm going to go to Excel. I'm going to represent this graph on Excel first. We will do the same when we will be dealing with categorical data. I can use either the class limit or the class boundaries. So I'm going to use the class boundaries here, 0.5 to 8.5. 8.5 to 16.5, 16.5 to 24.5, 24.5 to 32.5, 32.5 to 40.5, 40.5 to 48.5. So these are the classes. They could be the category that we are using. On column B, I'm going to enter the frequency. I could use the first row to put class limit, class boundaries, then I will ignore it when I am making my graph. So we have 14, 21, 11, 6, 4. You know, the difficult part is to get this frequency when you have, especially when you have a large data set. Once you have a frequency distribution, you don't really need to go through the much we did last time to make a histogram. Using that frequency distribution, this is from what the example we did last time. Now, I will highlight the data here, and I will choose insert. Now you can see several graphs here. You want to know that a histogram is a vertical bar graph. So you will look for which graph looks like that. We see this one. So we can choose this to have a histogram. This was done using classes and their frequencies. You can decide to reduce, you leave it like this is correct. We can decide to reduce the gaps between the bars by clicking Format Data Series here. And the gap width is very large here. I can reduce the gap width. I can make it 0 if I don't want any gap. So here I will put the title. The title, it depends on what graph you were using. I will just write histogram here for now. So if you are doing your homework, you can click copy and paste. You can move it around. So you copy this graph and you paste on your Word document for your homework. So there are other type of graph. We want to look at. If you are on Zoom and you have a question, maybe you are not seeing what I'm doing, just let me know, please. Sometimes I might not know that I have not put this work I am doing on the screen. So this is the histogram. Yes. Okay. We will go back to Excel to learn how to make the bars to touch. Let me separate them. You see here, when I right click, I will see format. It's from this formatting side. So I'll have this to be 0. If I am, this is how I can put the spaces back. So by taking it down, they are gone. You might don't want it all gone. You leave it where you want. But it doesn't really matter for homework or assignment. Most important is for us to see the bars. Some people like it close to each other. Doesn't matter. Okay. A relative frequency histogram is a histogram that you make by taking the relative frequency rather than the frequency. You are going to get the same graph because you have just changed the scale. The shape of the graph remains the same. So instead of writing frequency, where I was writing frequency, you write the relative frequency. So these are the instructions on how to use Excel to make a histogram. So one of the main advantages of a histogram is that it gives us the shape of the distribution of the data that we collected. If that data was from a normal population, for example, we will see the feature of a normal graph on it if it was a random sample. So graphs could be mount-shaped, symmetrical like this. It's a mount-shaped, symmetrical. It's a characteristic of a normal distribution. Graph could be uniform. That is, the frequency is the same for all the data. In this case, we don't have a mode because we are going to come back to the idea of mode. No, all of them have the same frequency. They are all essentially the same way. This graph is a skewed graph. It is skewed to the left. Skewed means reduced. It's reduced to the left. It's stepping down at the left. This one is skewed to the right, stepping down to the right. And here we have what we call a bimodal graph. It's a graph with two modes. Mode is the data value with highest frequency. Learned that in chapter 3. So when you look at a graph, you may be able to tell if the data is coming from a population with such a shape, especially if your sample is a random sample. So when you do your project, I think I will ask you the question, what is the nature of the distribution that you have? Is it approximately symmetric? This is approximately symmetric. Is it skewed to the left, skewed to the right, or none of that, or none of those? That's what you should be able to say. We also have cumulative frequency graph. In a cumulative frequency graph, we use the cumulative distribution to make the graph instead of the frequency itself. We use the cumulative frequency. It's a line segment graph. On a line segment graph, we can make a line segment graph with this data as well. But I just want to give you an example of line segment graph. We click insert, and then this is line segment. I click here, and we have a line segment graph, not this one. This was not the right one. This is a line segment graph, but it is not a nice one because normally it's supposed to go down to touch here, because I just used the frequency, the boundary points. To make a good one, I will use the midpoint and make the first frequency 0 and the last one 0 for it to touch the line below. This is just for you to see what a line segment graph is. This is not a good one. So if we want to make a line segment graph for the distribution that we have, we use the midpoint. Now I want to make a line segment graph for an OG, which is the cumulative distribution. Cumulative distribution is not just a line segment graph. It's a line segment graph for the cumulative frequency. We call it cumulative graph. So I will use the midpoint. We go back to the data, and you will see the midpoint of the data. Not the midpoint, I'm sorry. Okay, the midpoint is not here. These are the midpoint. That's what you use. You can use it to make another type of frequency, which is called frequency polygons. It's a line segment frequency. What we want to do now is a cumulative frequency or a cumulative graph. Cumulative frequency graph. We'll go back to Excel. I want to do it here so that you see how similar to what we did it is. The main difference here is that I'm going to use the class boundaries. Because in a cumulative graph, cumulative is for the highest data, the number of frequency in the data. I want to show you first what it is. These are the class boundaries. I'm going to start with 0.5, 8.5, 16.5, 24.5, 32.5, 40.5, and 48.5. Now the cumulative frequency. Cumulative frequency, the first is 14. And the highest is, we are going to get to 60. So I'm going to have 1, 2, 3, 4, 5. So at 0.5, we have no value. So we put a point here. You don't really need to do this. I'm doing it so that you understand what it is. We will use Excel. And if you like, you learn this one. But I'm doing this so that when I'm putting it on Excel, you understand what we are putting on Excel. So at 8.5, here is 10, 20, 30, 15 is somewhere here. So 14 will be somewhere. The next one is 35. That is 21 plus 14. 35 somewhere. And then followed by 35 plus 11, 46. 46. And then 46 plus 6, 52. 52, then 56, then 60. And then we will connect it with straight line. That's why we are calling it a line segment graph, because we are using segment, a line, to connect the point representing the frequency. So I'll start here with 0.5, 8.5, 16.5. I hope you know where I'm getting those values from. Then here I'm going to write the frequency. 14, I'm sorry, starting with 0. At 0.5, there is no value. Is the least of the, no value is below 0.5. So we put 0 there. At 8.5, there are 14 values below 8.5. At 16.5, there are 35 values below 16.5. Then there are 46 values below 24.5. That's the meaning of cumulative. Then there are 52 values below 32.5. Then there are 56 values below 40.5 and 60 values below 48.5. That is the cumulative distribution. Then now, I will highlight here and click Insert and choose a line segment graph. This is a line segment graph. I'm looking for the best graph that can be, I don't see it here. So I will go to more graphs. And this one look like what I want, but I want the dot to appear. So I will choose this one. So to move this, you see, when I put the cursor anywhere, if it makes this type of plus sign, that means I can move it. So you can copy and paste on your Word, or Control C and paste on your Word document. Yeah, if you are trying, you are going to see, because it is attempting to use these values. So you want to use a graph that would ignore that one. So if I come here, each of this graph, oh, I'm sorry. I need to highlight it first. You see, each of these graph is trying to combine those two. So just for you to know that none of them is going to work. So you come here and see more line chart. When I click here, it will give me more options. So I come and choose this one. Welcome. We are going to look at more bar graphs, more type of graph. When we are dealing with categorical data, you know numbers. So we will use the category in place of the classes that we are having, and we can make a graph. So you can make several types of bar graphs using those. When you go to insert, you might choose the type of graph that you want to make. I am teaching you some particular type of graph, and there are many other types. We can learn all of them. So we want to look at some few of them, particularly a Pareto chart. A Pareto chart is a categorical data. It's a categorical data that goes with category and numbers that we may call frequency, even though it might not be the number of times it occurs. Most of the time, it is the number of times it occurs. Sometimes, for example, we can make a chart of the number of COVID cases in each county. But we can also make a chart of maybe the average income of each county. Here, it doesn't tell us the number of things. It is just a number associated with a category. So whenever you have categories and number, you can make a graph. In a Pareto chart, it's like a histogram, but the bars are in descending order from highest to lowest. Okay? From highest to lowest. So for those who take class online, sometimes you have question of which of these graphs is a property of a Pareto chart. And I will say from highest to lowest, lowest to highest is a graph that represents classes and all those type of other questions. But you want to know highest to lowest. So let's look at the following data that represent the blood type, a class of 28 students, for a class of 28 students. And we will use a Pareto chart to represent it. I could ask you to give me your blood type. I don't want to waste that time. That's just what we did to get this one in one of the previous classes. So we get this data, and we can use it to make a Pareto chart. So blood type A is 8, blood type B is 6, blood type AB is 4, and blood type O is 10. Let's go to Excel. You can easily make it on the graph and so here is A, B, AB, O. So this is a simple data set. It could be county, Cambria, Blair County, and all of the counties in Pennsylvania. It could be anything. It could be schools. It could be classes and the average score in a test. It could be anything as a category that you put in column A. In column B, you put the number associated with each of those categories. So we highlight the values. We want to make a bar graph where numbers are in order. We have only 4 values, right? So we can decide to arrange these 4, starting from the one with the highest frequency before we make our graph. But to do that for 4 is not difficult. We will see that O is the highest, then A, then B, then AB. But if we have 100 values, we cannot just do that. Remember how we did last time with Excel? We are going to highlight the values. Just highlight the values and sort it now from largest to smallest. We want to sort from highest frequency to smallest frequency. So it's not going to work because it will want us to know that by doing that, we are going to readjust column A. So I'm going to say, okay, there is a better way to do it, but I don't want to mix many ways of using Excel. I want method. So then we have arranged it. And we now go to insert and use this graph. I did not select the graph. I did not highlight. You have to highlight this before you go to insert. So we have a Pareto chart. You can adjust, you can change color, you can make it, you can choose any of these. You can put color. So as I said before, you can always reduce this gap. I will show you again. Make sure that your cursor is on one of the bars. And you right click and go to format and then reduce it as much as you want. If you let it touch, that's not problem. So this is a Pareto chart. Another type of graph that is commonly used in statistics is a circle graph. That is, categories are represented on a circle. Each category takes a section proportional to its size with respect to the frequency. So we are going to do exactly the same thing. So I'm not going to go back to teach that. I will just do it here. We highlight the data. You don't have to organize it. They were in order as I did here. We highlight the data and then we go to insert and we are looking at a circle graph. This is circle here. So we can choose any of this and we have a circle graph. I want to move this here. So we can choose any of these ones. You can choose the one that is most appropriate for your audience as you want to make a presentation. So we have learned how to make a histogram for quantitative years. How do we get? Just click, it will come in. I will ask you percentages, okay? I will ask you to make a frequency distribution table, including percentages. Sometimes I do that. You can just make your circle graph and come and copy it. Do we understand what I'm saying here? in the process of making, if I choose this one, there will be no percentage. Okay, look here. When I did it, it offered a lot of options. The same thing for this chart. I can make a chart that does not have numbers, like this. Anyway, all of them have numbers. I'm not just saying them. So you can choose any of them. It offers you options according to what you might want your audience to see. So when we are on a circle graph, you can choose any of these. Some of it will have it as percentage. Some will have it as numbers. All of these are percentages. So I usually ask to make a column for percentage. When we started, remember we had category, frequency, percentage. We can also use angles. That is, you divide each frequency by the total and multiply by 360 degrees. But I don't usually ask that. I just want percentage. Any question? This is about graph. So we can skip this. In a time series graph, generally time series graph goes with what we call cross-sectional data. In cross-sectional data, you collect data from different zones or different places at the same time. In time series graph, you collect data over a sequence of time. For example, I might want to collect the data of how many students take statistics each semester. And that is for spring 2021, fall 2021, spring 2022, and I can have a time series. What is the temperature every day? On Monday, on Tuesday, on Wednesday, on Thursday, on Friday. Like people want to know how many people were tested positive, newly tested positive, every day of the week, every day of the month, every month of the year, every week. When you have a series of time, you call it a time series graph, okay? It occurs over a sequence of time. Let's do this example of a time series graph with these data values. Suppose you have been in the walking or jogging exercise program for 20 weeks, and for each week you have recorded the distance you covered in 30 minutes. Your data is shown. We want to make a time series graph for this data. So week 1, week 2, week 3, 4, 5, 6, 7, 8, 9, 10. So when you have 1, 2, 3, 4, 5, it's always by default. Even if you don't write it, that will show on your graph. But I am putting it, we could say week 1 or day 1, day 2, day 3, and we will see what will be on the graph. Now, it's more serious now, 1.5, 1.4, 1.7, 1.6, 1.9, 2, 1.8, 2, 1.9, 2. As I say, always make sure you enter the data correctly. something. If you see me doing something wrong, will you tell me? When you're looking at what I'm doing, if you see that it's wrong, tell me. Don't just assume that he knows what he's doing. Because I miss a step here, I miss 18. So when you are looking at what I'm doing, be checking as well. So we have our data recording, 20 weeks of exercise. I want to think that everybody, you can use this one. So we are just going to do the same thing, highlight the data. I want you to, there are many methods of making graph, but this is the simplest one which I want you to learn. Highlight the data, and then insert, we go to the time series graph is a line segment graph. I will go to more chart, and this one is the best one. So I want this. That's not what I choose. So I want more chart. Something like this. So this is a time series graph. We can make it bigger, and I will show you the pattern of occurrence. This was the time running. The difference is not too much. So you could write week 1, week 2, week 3. That's what I want you to see. I'm not writing it for all, but you could write the category, I mean, the 2001, 2002, 2003, January, February, March. That's what you can write there. Day 1, day 2, day 3 to make a frequency polygon. So you have the frequency polygon here. This type of sign, you might see it in some graph. It's just to indicate that it's not at scale at this level. We are going from the distance from here to here is not reflecting from 1 to 2 here that we have here. So because it is the distance around in 30 minutes. So you have here the steps to follow in using Excel. If you forget, you go to the PowerPoint. Stem and leaf display. In a stem and leaf display is a method of organizing data in which we divide the quantitative values we have into 2 parts. One will be considered a stem and the other will be considered a leaf. In simple situations, we have 2-digit values, and we make the first digit the stem and the second digit the leaf. And then we write the stem and put leaves to each stem. It is a method of exploratory data analysis which help us at the same time organize data and then to have a shape of the data. We don't use Excel to do that because it is not difficult. So If you have data, for example, up to 50, you can say the stem are 1, 2, 3, 4, 5. Or 0, 1, 2, 3, 4, 5. That is the first digit. If you have 2 digits, maybe your numbers are from 100 to 200 or 300. You might just say that the first 2 digits are the stem and the last digit is the stem. It's the leaf, I'm sorry, stem and leaf. Let's look at this example. We look at the data and we see that the lowest value here is what? 0. And what is the highest value? Highest value? 45? 51? Okay, 50 something. Let's just say 50 something. 51, right? So what we want to know is what are our possible stems? So we are going to write, I'm putting these lines because on the board I might not follow the line carefully. So I will have 0, 1, 2, 3, 4, 5. These are the stems. And here we are going to write the leaves. So when we read a number, we write the second digit behind the corresponding stem, which was the first digit. What is the first number? First number on the list. 30. That's the first number, right? We just want to read all of them. 30, so I will write 0 here. The stem for 30 is 3. The leaf is 0. Okay. The next number, 27. What is the stem? And the leaf. Then 12. 42. 35. 47. 38. 36. Can we continue this? Right? We can continue to complete the stem. I will not continue. I will just show you what we will get. So this is what we will get. Then we can decide to organize it in order. You see, we have 3, 0. It's better to write it 0, 3. That is in ascending order. So when we organize it here, we have 2. There is another 2. Then 7, 8, 8, 8, 9. So this data give us at the same time a data organization as if it was in classes, and also like a kind of graph, which is like a histogram, a horizontal histogram. So we can also visualize a kind of shape of that distribution here. So if I ask you, how many values are less than 27? How many values are less than 27? How many values are less than 27? So this is 27. So you are going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Kind of, okay? You just count the number of values that are less than. You should be able to know where 27 is. Someone else might think this is this one, but generally when I ask you a question, I will not choose this kind of numbers. I can instead say for maybe 29. How many values are less than 29? Or how many values are less than 36? so that you don't get mixed. Generally count all to the highest of that number. Or that number will, if it is less than, it's less than. 27 is no less than 27. So that's the stem and leaf display. No, yeah, good question. Good question. So we start with the first digit was, sorry, the first number was 0. If the first number was 1, the first term will be what? If the least number was 1, the first term will be what? That's what I want us to clarify. It will be 0, yes. No. When you have decimals, get rid of those decimals, and then you will see a pattern that can help you to get this term. I want you to understand that these things we are doing are options that people can use to express their data. If your stem and leaf is not going to help explain what you want to explain, you don't just use it. But if you have to use it, make sure it is well describing the data you have. But for our class, generally, I give you this kind of numbers that you can understand that these values are, what are we doing? We are just trying to group it into classes in some ways. One class is from 0 to less than 10, and then 10 to less than 20. Then, so sometimes your data might have decimals, as you are saying. These values could be like 3, maybe 3. I am dividing everything by 10. 3, 2.7, 1.2, 4.2. And you just say this. You multiply everything by 100 or by 10, and then solve it to make that. What you want is to organize your data and to see a shape. Okay. So we are done with chapter 2. And I think we are done with the class. We can continue chapter 3 on Thursday. Hoping that the weather is not going to be too bad. So if it is, when the weather is too bad, you know what we will do, right? Everybody will be on Zoom. So because I didn't tell you yesterday, I was still contemplating. When I saw outside, it was not that bad. So I could have sent you an email at 10:30 to tell you that we will be on Zoom. Yes. You will do like you are doing your take-home problems. You will come to class with your laptop, you will upload the exam, but if, yes, yeah, that's it. You got it. It's because of Excel. Some people still want to draw it. There will be no problem, but I encourage you to practice using Excel. Make things much easier. Yeah. So you will copy and paste. And you're not going to be writing everything. You can just copy and paste. The color of your head, you just copy color of your head and it is faster. Don't type everything. You copy and paste sometimes if horrible things you forget to change. Yeah. No, just leave it as it is. I don't want to work much of that. I want you to be able to use Excel to make graphs. When you look at that graph, you will see somewhere where you can put what is on the y-axis. But for now, I want you to be able to make the graph. Once you have that graph, it's good for me. If you make it better, that's still good. But you find when you are able to use Excel to produce the graph. So because of the weather, no attendance today. Okay?